Hi guys, hope all of us are doing great. My name is Ernest. I'd like to welcome all of us to our channel of Ernest's Sciences and Mathematics TV channel. In our channel, we deal with different aspects of physical and biological sciences, and also we deal with the aspect of mathematics, both in discussion and trying to solve problems here and there. So for today, I'm going to look at a basic concept in which is going, of course, to span across chemistry and physics, and that is the concept of anatomy of a wave. Now, this is going to assist us in trying to figuratively describe some aspect of an atom that we have already tackled in our videos. So this is basically the concept of a traveling wave. And this is going to open for us a window in describing the wave mechanical model that we had given in one of our videos on the concept of an atom. And also it's going to give us an insight on the electronic structure of an atom that is basically pertaining the present understanding, especially in various areas that we're going to tackle in quantum mechanics. So without further ado, thank you and welcome. So as I've said, today we are going to look at a short concept basically on a traveling wave. So in one of our videos that we had discussed the concept of a wave, we had given just on a shallow note the anatomy of a wave, and that basically is going to assist us in trying to understand some of the concepts that we have already discussed, of course, concerning the introduction to quantum mechanics. And this aspect of a wave, of course, is going to give us an insight, as I've said, in these various topics. But of essence for us to learn is that the wave mechanics is going to, particularly in this discussion, is going to open for us a window in discussing electronic structure of atoms that is going to be based on specific quantum numbers, just a bit legible. So this is going to assist us in trying to discuss the specific quantum numbers that we're going to encounter, particularly in trying to describe the different aspects of an atom, or rather the electronic structure of an atom. Now for today, we're going to look at the anatomy of a traveling wave. So therefore, I'm going to have an illustration on the board which is going to assist us understand basically what are these different parts. And whenever we are having this discussion or various topics in quantum mechanics, therefore we're going to refer to some terms from this specific video, which are going to assist us understand basically what aspects of this wave model we are talking about. So therefore, in this case, I've just given an illustration that entails this aspect of having this two-directional, which is going to give us a motion in two-dimensional space that we have already talked about in some of our videos, and also maybe in the concept of graphing. So basically, I presume that we're going to look at this one in that particular case, or rather in relation to that particular case that I've just mentioned. So we're going to see that wave mechanics or wave motions basically is going to entail the transfer of energy and not matter. So therefore, suppose I just try to give this one as an illustration of those just two direction for x and y axis. Therefore, I'm going to have this one as a positive direction and this one as a negative, just for the sake of this specific illustration. So therefore, we're going to see that a wave consists of repeating units, which are going to be referred to as cycles. So these are repeating units that we're going to refer to as cycles. And we're going to have a specific name for this particular aspect that we have referred to as cycles. So therefore, we're going to see that the distance between, so this basically part of a wave from this particular section, which is the uppermost part of a wave, we refer to this particular part as a peak. And this is basically implies the distance from this x-axis to this particular point, which we are going to give a name, but the uppermost part of this particular section of a wave is referred to as a peak. Now, this, as we have said, that this wave goes in a repeated manner from its particular description, whereby we have said that a wave consists of a repeating unit called cycle. So from this particular peak to the second peak, let's call this one P1, and this second one P2. Now the distance from this particular peak to the subsequent or the following peak from P1 to P2, this distance is referred to as a wavelength, and we're going to give it an initial lambda. So lambda refers to the wavelength, which is the distance between a peak to a peak. And in some cases, of course, we're going to have this lower part of the wave, which are going to be referred to as a trough. And basically, if I may just use this specific illustration, so we have the fold which goes on the upper part for the positive and the lower one. This is going to be referred to as roughly as a trough. And also we are going to have also a different description for that. Now the distance between this x-axis from the 0 point, before we describe the positive or negative, therefore at this specific point, the distance between this x-axis and the peak is referred to as amplitude, and therefore this refers to the distance or the half vertical distance that is between the x-axis and the peak, which we refer to as the amplitude. Now the amplitude is half the vertical distance, and the point at which the amplitude is equal to 0 is known. So suppose we were able to give these specific parts a scale, and then say this is a negative unit, which is -1, and this is 0, and this is a positive, which is 1. Then at the point at which the amplitude is equals to 0 is going to be referred to as a node. So therefore I can just pick this specific point, we can just give them a name. So a single point at this particular point of the junction between this moving wave and the x-axis is going to be referred to as a node. Now we had talked about some of the characteristics of a traveling wave in one of our videos, and we are going to see that one of the characteristics of a wave is that it possesses what we call a frequency. And the term frequency basically refers to various the cycles, the number of cycles which are going to be experienced in this particular wave per second. So therefore it's a ratio between the number of cycles per second of this particular wave. And we're going to denote this wave using the Greek letter mu, which basically is going to be denoted using that particular notation. So therefore this frequency is measured, as we have said, is a ratio. It's going to be measured using the units of per seconds. So per second is going to be the unit that's going to be used to denote frequency. As we have said, it's a ratio of the number of cycles per second. So these various parts that we have listed for wavelength, which of course is the distance between a peak and a peak, or a trough and a trough. And then we have talked about the distance between the 0, which is the x-axis, and then this topmost part of this wave is referred to as the amplitude. And then the distance between the successive, of course, peaks, we have said it's referred to as a wavelength, which is denoted by lambda. And therefore the number of cycles of this traveling wave, which are going to be, of course, number of waves per second, is denoted using this particular letter mu, which refers to a frequency. Therefore these particular three terms, which are referred to as the frequency, the wavelength, node, and then we are going to encounter other various terms that we can be able to use, or the various aspects that we're going to use to describe a wave. And basically for this particular anatomy, we had said that our main objective was to try and have a figurative description of this. And this is going to, of course, assist us in the long term in trying to describe, of course, the various models that we have discussed, specifically the wave mechanical model that was advanced of describing an atom. And generally the wave mechanics, as we have said, is going to assist us in trying to describe the electronic structure of an atom. So catch us in other videos, short videos, that we're going to look at the various aspects of this electronic structure using this wave, traveling wave, as one of the ways of mainly describing these various aspects of the electronic structure. So for that case, I'd like to request us to catch us in our next video, and that is where we're going to wind up for today in this specific video. Bye. God bless you.